This
All
is
right, so yeah, I guess I'll.
yeah, this is the OSS team demo week, July week 3, and we're starting off with James showing us some demos.
Cool. So yeah, this one here is a localhost installation of Kubernetes, and using this localhost.in.lumen.com, it's just a DNSA record points back to localhost. So this is running on my machine, and um, AutoComplete should be quite a bit snappier with this here. As you see there, it was like instantaneously. I just click a button, it was fast, right?
Mhm.
So whatever. Same thing running on the cloud. This one is a real domain running on a Google Cloud project. And same thing, super fast autocomplete because it is using SSL. So kind of show a little bit of the dashboard that we're working with here. So this is the real Google Cloud platform for this particular revision. This version of it, this is a single node, single replica set, one pod, one machine, no routing. That's kind of the next steps. But for this one, you got all your different pods. You can go sneak into them, look at the logs independently inside of the control panel, and leverage all your usual Google tools that have a million features and have a look at that. And then when you're running localhost, you get what's called the Minicube Dashboard. It's kind of the same thing, but a little more stripped down. You can go have a look inside any pod, and inside that pod, you can get into your logs and see what's going on from the top to the bottom. I'm not sure if you guys are interested in seeing the actual code underneath it or not, or if I should hand the mic over.
I'll take a quick look at it, sure.
Okay, so basically this entire deployment is coming from one YAML file for now, and this YAML file's got everything in it. These are just the certificates for the star.localhost into Lumon, and basically this would never make, you'd never commit these into your actual code that we push, and I have not pushed any of this to GitHub ever, but in a real system, you would be populating these through a Helm chart. So they'd be coming from a different location. You would never actually see the secrets. They're not a very good secret if they're in the public GitHub. Next up, we get a config map, which is basically just an arbitrary way to stick a file anywhere you need into a pod. And this one is the Envoy routing. Colin helped me a lot with getting the actual TLS part of this with the socket set up correctly. So you can see here where it's using the etc SSL TLS.cert. That TLS.cert is the same secret from up here, but it's mounted inside the running pod. So this config map is just the envoy.yaml that gets used. Next up is a service. A service is basically a way of taking any container and exposing it to either the cluster or the outside world. In this case, node port means outside world, and we take Envoy's port 10,000, map it to, you got to pick a value above 30,000, so I picked 30,080, and this just basically says on the Minikube that's running on my machine, which is basically just a Docker container that runs Kubernetes, to expose port 30,080. What I've done is to port forward that on my machine to the different port that I'm actually using. I think it's 7890. I'm just doing that here so that I can get the certificate using the DNS record pointing to localhost into Lumon. Finally, the deployment is where all the actual running code happens. So this is right now my replicas are only one, but when we crank this up, we can have as many as we like. And this is what defines all of the different file systems and the containers that we are running. So I've got a gRPC container, using a local build, and the proxy container. I don't think it's even necessary anymore with SSL present. The web container, I did nothing here. I just literally mounted it and it worked great. Envoy exposes that for us. And then for Envoy, I am not using the Deephaven built one. I'm just using a stock one because I'm supplying my own YAML. That will allow us to parameterize and not really worry about any of the settings that we're using elsewhere. And so that's the entire 400 lines of YAML gets this thing running in Minikube and exposed to the world.
Cool.
So the instructions for it, or the process of building this, is quite nice, because I can just literally run Gradle prepare compose, and it will rebuild our Docker images inside of Minikube. So that way, it's like I'm working in a real Kubernetes cluster on a different machine, but it's all on my laptop and runs super fast. So autocomplete, very fast, just like I was used to. So
All right.
That's it for me.
Yeah. Now, you mentioned that autocomplete is faster over SSL. Why is that?
It's not opening millions of connections. It's just opening a single connection, keeping it open, and piping everything through it.
How come it opens a whole bunch of connections without SSL?
That is more of a calling question, but I believe it's because when we're proxying, we're going from HTTP1 to a proxy, then to HTTP2 to gRPC, and then back again. And so every connection is actually 2 REST connections back and forth. And as you can guess, that's not very fast. Even on localhost, it's slow, whereas now even on cloud, it is fast.
Yeah. Okay. Cool. Sorry to distract there. All right. Anything else from James? Otherwise, we'll move on to Devin.
Yeah. Great. Go ahead and present my screen. I have got a couple of command line applications. Let me find my window. My favorite type of GUI to demo. Are you guys able to see my screen here?
Yep.
So I've got 3 command line applications that I want to demo today. Big thanks to Nate for getting some of this stuff out so I could run with it today. What we're going to be looking at is a simple Java client that can list tables from a remote server, publish tables to a remote server, and then graph those tables. What I mean by graph, it's really just translate it to a different format, the QST. So let's go ahead and look at list tables. And so by default, this is connecting to localhost 10,000 without any arguments. And there we go. We've got some flight scopes here, and I've got 4 variables set. If we want to get some more information, we can give it a schema flag here, and that's documented in the help here as well. Go ahead and get the schemas. So those are the schemas for those tables. You can see this is some sort of aggregation. We've got a time table and some other random tables here as well. So let's say we want to publish a table to this server. What we can do is we can choose our QST and we can give it a key name. So we can say hello world equals big ag. And what this is going to do is going to send this query off to the server and then publish it or bind it to a variable. So I'll go ahead and do that. And it's not going to return until the actual first table creation is complete, and that's done. And then we can go ahead and list the tables again. And there we go. We can see hello world there. If we wanted to connect to a different server, I've got another server running on my machine. You just give it a different port here, and all these commands take a target. So you could do that, and we can say, oh, there's another server right there. One other cool thing that I want to show is this graphviz command. And so this will take a QST and output it to another format. So if you want to see what was this aggregation that I sent to the server kind of in a dot format. So by default, this outputs to dot. We can go ahead and do that. And this is a textual graphical format. We could output to PNG, SVG, JSON, plain, PostScript, a bunch of other ones. But for example, if we wanted to do SVG real quick here, it takes a little bit longer when you're doing not dot files, but there we go. There's the SVG. And for fun, I'll go ahead and show you what these graphs look like. Let me share another screen here. So here's one of the tables that we saw earlier. Are you guys able to see this? Mm-hmm. So this is a graphical representation of the DAG. It's not fully fleshed out yet, but that's it right there. And then here, so that was the one that I sent to the server. And here's one that I created, a couple months ago for fun. This was a 4-bit adder. So this is adding 2 4-bit numbers together using Deephaven, 8 plus 3. And you can see there's a lot of logic in here that, kind of went in here. So I think a tool like this will eventually be useful for helping to understand DAGs and document stuff, and potentially, teach other people about how things are composed together using Deephaven queries.
Yeah, or scaring people when you say adding 2 numbers together is.
But this is exactly the kind of thing we were hoping to build out of the QST, so I'm excited. It's really cool.
Cool. Okay, cool. That's it for Devin. Okay. Any other questions for Devin? Okay, and I guess it's me. So let me share my screen here. And 1 second. Share screen. Touch screen. Okay. Now I've been working on getting the hold on a second. I might not be ready for my demo. I might be screwing something up here. In which case, I should not be showing it. I was going to show the console types, how it should just load now, but I think I rebased off another branch and I've broken it, so I will not demo it. I'll have to look into what I need to fix there. Because, I know what's happened. I didn't rebase. I rebased my UI branch, but I didn't rebase my server side. So I'll have to fix that. And I'll just stop presenting now. That's kind of an anticlimactic end of the demo. But sorry about that. All right. And we'll see you all next week. Cheers.